Hi, I am Kumar. Welcome to today's video. Let's get set and learn. In today's video, we will see introduction to programming languages. So what are we going to see today? What are programming languages? Why are these programming languages important? We'll classify programming languages into different types and we will see some approaches for programming languages. Those are called programming paradigms. And then we'll wrap up. So what are programming languages? So generally people communicate with each other using a language. Like English, I am currently speaking to communicate with you. So to communicate with computer or to ask computer to do something, you need a language. That language is called programming language. So now let's say we are communicating and I want to tell my name is Kumar. I cannot tell my name or Kumar, my name am Kumar, all those things I cannot tell, right? So English has a grammar. Each language has its own grammar so that other people can understand. If you speak wrongly, it's difficult for others to understand. Similarly, even programming languages have grammar. It has set of instructions that computer understand. You cannot write your own instruction, then it will be difficult for computers to understand. So programming language is a formal language that specifies set of instructions for a computer to perform set of tasks. Examples of programming languages: Java, C++, Python, Go, JavaScript, all these are programming languages. Now let's see why are these programming languages important. So first and foremost is communication with computers. You can use this language to communicate with computers. These languages provide set of instructions and you can create a complex software out of it. Next is efficiency and automation. Programming languages help us automate tasks and processes. Like you can automate repetitive tasks. For example, you are a class teacher and you want to create a scorecard of whole class whenever some exam is conducted. So what you might have to create, you might have to calculate score of all students. You might have to calculate their average. You might have to grade their students like first rankers and top rankers. And you might have to tell which students have passed, which students have failed. So all these things you can automate using a software. So once you conduct an exam, just feed the data to your software. It will generate the whole scorecard and you will be done within minutes. Next is software development. This is the most important thing. This is why programming languages are created altogether. So nowadays you will see lot of apps, mobile apps, video games, web browser, all the things you interact with computers or mobile are built using software or built using programming languages. Next is data analysis and insights. In today's big data world, this has become more important. So people are using programming languages to analyze lots of the data and derive insights out of it. They also use machine learning models to predict and recommend something. So these are the reasons programming languages are very, very important. Now let's see differences between different types of languages. So we will see how languages are classified into different types based on different things. First, let's see high versus low level languages. Basically, computers can understand only zeros and ones, binary, only zeros and ones. If you want computer to do anything, you have to tell it in zeros and ones. But humans do not understand zeros and one. Like humans understand, but it's very difficult for humans to write always in zeros and one. We don't speak in zeros and ones. We don't write in zeros and ones. So it's difficult for humans. So programming languages are made so that it is easy for humans to write a code. And these compilers or interpreters, whatever it is, they convert your code into machine code that computers understand. So what are high level languages now? So high level languages are languages that is made so easy for humans to understand, but the compilation part or the processing part is quite intensive. So high level languages are easy for humans to read, low level languages are not easy for humans to read. Next is abstraction. So abstraction means you don't know how computers are converting your code to binary. You just know how to write your code. So the more abstraction, the more it is easy for you to write the code. The less the abstraction, the it will be hard for you to write because it's difficult for you to understand. So high level languages have more abstraction, low level languages have less abstraction. Next is performance. Since high level languages have so much computation you have to do, to convert into machine code, the performance for them is slower, and low level languages performance is faster. So examples of high level languages: C++, Python, C, Java, all these are high level languages. Low level languages are like assembly languages. So if you see an example code, int sum is equal to a plus b. So what do you understand from this statement? Even if you don't know any coding language, you can see that we just have to add a plus b. It's easy to understand. Now see, you can see an example of assembly code. It is like move, mov, eax a, add eax b. All these things are written. So it's difficult to understand for you. Now let's see how we are classifying programming languages based on compilation. So what are compiled languages? First, compile your code using their own compiler. That means they convert your code, whatever you have written, into machine code, and then you execute your code to get the result. So there is a two-step process. First is compilation. You convert your code to machine code. Second step is you execute your code and get the results out of it. In interpreted languages, these two are done at single time. Only one step is there, execution. In execution, in interpreted languages, your code is interpreted line by line. That means the whole code is not converted into machine code. Each line of your code is converted into machine code on the fly during execution. So since your full code is converted to machine code during compilation, now you just have, when you're executing your code, you just have computer instructions and it will be faster. Since you are interpreting line by line, at every step you have to convert your code in interpreted languages, convert your code into machine code, and then execute. It will be slower. So if you see case of debugging in compiled languages, you can, most of the errors you can catch during compilation. So that since it's a two-step process, most of the errors you can catch in the first step itself. But in interpreted languages, all the errors are catched during execution. Examples of compiled languages: C, C++, and Go. So in C, C++, you have a compiler, example GCC compiler, that will convert your whole C code into a machine code, and it will give you executable files. Now you can run that executable files. Those are like machine code to get your output. Some examples of interpreted languages: Bash and JavaScript. So in Bash, you write set of instruction, and when the Bash script is executed, each instruction is converted into machine code, like it is interpreted during execution. So this is compiled versus interpreted language. Next, in this slide, we will be classifying languages based on data types. So type checking, statically typed and dynamically typed languages. So in previous videos, we have defined data types. So what is a data type? Data type of a variable means you define what type of data a variable holds. It can be an integer, it can be a character. All these are data types: integer, character, boolean, all these are data types. So in statically typed languages, you define these data types beforehand. So you have to define the data type or else it will not work. In dynamically typed, it is not necessary to define a data type. It is an optional, or it is not required. So type declaration, even before executing code, you have to declare the type. In dynamically typed, it is declared during execution. That means your interpreter or your compiler will see what value you are storing, and then it will determine what type it is. Type check. So this was declaration, but when the type check will happen, whether the type you are giving is correct or not. So in statically typed languages, it will happen at compile time only, but in dynamically typed, it will happen at runtime. So why is performance better for statically typed languages? Because you have predefined the types. So computer now knows how much memory to be allocated, what things have to be done, and it will optimize for it. But in dynamically typed, you don't know what will be your data type. You might have to add more memory, or like the process will be bit slow. So examples of statically typed: C, C++, and Java. Dynamically typed: Python and JavaScript. So if you see this example code, what is the difference? Only this int part, right? So this we have to declare in these languages beforehand. This is a is int. If you write int a is equal to high, it will give an error because it's not an int. But in Python, you can write a is equal to 5. and in the next line you can write a is equal to high. So it will run, and when you print a both time, it will say in the first run it was 5, in the second run it's high, and it will not give error also. So that is why this is the difference between static and dynamically typed. In statically typed, if you know beforehand what are the types it is going to be, you can use statically typed languages. But if you want flexibility, you can use dynamically typed languages. We have classified programming languages into multiple types based on multiple categories. Now let's see different approaches to program. So you might program in different way, some might program in different way. So these people have created programming paradigms also. So some languages support some paradigm, some languages support only one paradigm. So some languages might support all of these paradigm. So it's not specific to language that one language supports one paradigm. It can be multiple of these. But this slide just explain what are the approaches that you can use to program your code. So we will see an analogy to understand this better. So let's start. First is procedural programming. So in this type of programming, you just write programs as a set of instructions. So you will just write series of steps and it will execute. So let's take an analogy for all this example. Let's take baking a cake. So you have to bake a cake for maybe your son's birthday, let's say. So in procedural programming, it is like you are given a recipe. You take that recipe. First step is maybe take some items and you follow that recipe and bake a cake. Similarly, in procedure programming, there are series of steps. You follow step-by-step instructions and write those instruction and do the task you want to do. Example C. C follows procedural programming. Next paradigm is object-oriented programming. So this we have seen basic OOPs. We understood what is OOPs and what are classes. All this we have seen in a video. So in OOP style of programming, you create objects. You create like, for example, baking a cake. If you take, you define objects like mixer, oven, or human. Human is what you. So human can mix. Human can add ingredients. Human can mix this. Human can lift the lid. Human can do lot of things. And mixer can mix the ingredients. Oven can bake your cake. All these are different functions. You will different methods you will create for each classes, and then you will instantiate an object and bake the cake. So this is in the end you are baking the cake only, but you are doing using different style. So in procedural, you did it by series of steps, like following a recipe. But in object oriented, you created multiple objects and called different methods and executed baking a cake. The next type, it's a functional programming. So in functional programming, it is a style of programming in which you program like a mathematical function. Let's say one simple mathematical function, addition. So when you add two numbers, you will get a result. That is a mathematical function. So even when you pass, let's say 3 and 4, you have to add 3 and 4. It is 7. Even if you pass this 3 and 4 1,000 times if you add, you will always get 7, right? So functional programming treats your functions, whatever you define in your code, as pure functions. There are no side effects. So there is no something like based on different state, you might get different output. No, those are pure functions. So if you take in examples of that baking a cake, for baking a cake, always baking, the temperatures are same, everything will be same. You will not change that. So that is how functional programming is designed. And there are some languages that follow functional programming, Scala, Haskell, all those things are there. Some examples of object-oriented programming, Java, Python. So in Python, you can also do functional programming, but it's not supported out of the box, but you can always do that. This is just a style of programming. Next is a declarative programming. So declarative programming is style of programming in which you just specify what has to be done. You don't care about how it will be done. So it, like in baking a cake, you just hire a cook or you just order your cake. So that you will tell that cook, bake cake, use these ingredients. It will, the cook will do and go. You will get the cake. In all this example, we have seen the objective is the same, only the style changes. So these are different styles of programming. So examples of declarative programming, SQL. So in SQL, we just tell what data you want, but SQL will see how he has to get the data, where you have to fetch the data, how you have to aggregate, all those things SQL will see. That's not your job. You will not write instructions. That's how SQLs are written. It's like highly abstracted language. So let's wrap up. Today, what we have learned, we have seen what are programming languages. We have seen different classification of programming languages. So we've seen high versus low level languages. We have seen compiled versus interpreted. We have seen statically typed versus dynamically typed. We have also seen 4 different types of programming styles, like procedural, object-oriented programming, functional programming, and declarative programming. That's all, folks, for today.